everyone. My name is Hikaru Saito from Aeon Smart Technology. I'm very honored to be here. Today, I'm presenting on how Aeon has enhanced its technological maturity and market competitiveness through platform engineering. Our goal is to leverage technology to provide the best experience for our customers. Thank you for joining. Let me introduce myself. As I mentioned before, my name is Hikaru Saito from Japan, and I lead both the SRE team and the platform team. I'm passionate about Kubernetes, Azure, Terraform, and Vault. I'm certified as a Kubestronaut and hold HashiCorp certifications. This QR code links to my X account, so feel free to follow me if you'd like, but I not in Japanese. Do you understand? On to the main presentation. Aeon is one of the most biggest retail company in Japan. It was founded in 1758. And today, we have over 300 subsidiaries and more than 600,000 employees and operate over 17,000 stores across 14 countries. Throughout our history, we have continuously grown and evolved to better serve our customers, expanding into both physical stores and online markets. We are developing diverse businesses with a focus on retail, and as a group, we are working to enhance business value. Specifically, we have business in finance, healthcare, supermarkets, and more, and the synergy between these is an important factor. Here, I would like to highlight Aeon's philosophy. Give the central pillar wheels. In Japanese, 大黒柱に車をつけよ. It means adapt to changes in the environment and transform the company itself. This is an expression that symbolizes the agility of a company and has become an important philosophy in engineering as well. Today, I'll share how Aeon has achieved success in engineering by applying this philosophy. The retail environment is changing rapidly. Customer behavior, lifestyles, and technological innovations are all influencing our business. As customer expectations increase, we focus on delivering a seamless shopping experience that integrates both physical and digital elements. Aeon's digital transformation challenges consist of 4 keys. First, transforming its business into seamless shopping experience that integrates both physical and digital elements. Second, building a customer-centric ecosystem through the use of technology. Third, creating new revenue models through data integration. Finally, revamping existing operations by using data and AI. To achieve this, we have set several key pillars: customer centricity, agility, security and governance, and data-driven decision-making. By focusing on these areas, we are building a sustainable and competitive platform. Aeon Smart Technology leads the digital transformation of Aeon Group and promotes in-source development. We have introduced agile methodologies and fostering a new culture that aims to enhance technical capabilities across the organization. Now, I would like to address journey to obtain higher platform engineering maturity. First, I share history of cloud adoption. We have been using the public cloud for over 8 years, mainly utilizing Azure. However, as our business has grown, complexity and cognitive load have increased, leading to inconsistent architecture. To address these challenges, we have focused on advancing our platform engineering. The primary goal of platform engineering is create an environment where the application development team can focus on their core activities. By reducing the cognitive load for developers to manage infrastructure and tools, we aim to ensure that they can provide the best possible customer experience. Ultimately, this allows us to maximize the value we deliver to our customers. When starting platform engineering, one key consideration was to avoid beginning with the introduction of internal developer platform. Everyone here knows there is an excellent product, of course, Waypoint or a backstage and something like that. However, we needed to establish foundational tools, infrastructure, processes first. The following is a quote from an article by Wiley titled Platform Engineering, the Next Step in Operations. The fantasy of platform engineering is one-click deployment. I strongly resonate with this statement. Let's take a look at the overview. We are implementing platform engineering in 4 steps. Step 1, build team and reliability. Step 2, wiki and inventory. Step 3, standardization and higher usability. Step 4, self-service and IDP. First, let's go over step 1. The first step in platform engineering was team building and establishing reliability. We initially formed a combined SRE and platform team, working closely with the development team to identify and eliminate the high-toil tasks. This helped us build trust and enhance the platform's reliability. What's important here is to start with collaboration. You can achieve self-service right from the beginning. By collaborating and maintaining close communication, you can identify the issues. Through the process of establishing solutions, it becomes possible to turn them into services, like X as a service. This is also mentioned in team topologies. Have you read it? This book? And in this team topologies, it is further explained that while collaboration can be costly, but it is ideal for exploring new approaches, whereas X as a service models are suited for predictable delivery. As teams deepen their understanding of technology and products through exploration, the need for close collaboration decreases and the number of collaboration targets narrows. As product and service boundaries become more defined, many organizations transition to X as a service. In larger enterprises, this discovery or exploration to establishment pattern is expected to continuously occur across teams in different stages of deployment. development. Here are some examples of toil, creating cloud accounts, determining architecture, application deployment, platform stack deployment. These are common examples of toil, but each one is fundamental and important. In summary of step 1, the goal is everything from team building and reliability. The outcome, the reliability was built or the reduction of human resources for deployment, increased deployment frequency, reduction of incidents triggered by deployments. Now, next is step 2, wiki and inventory. The next step was setting up a centralized inventory of platforms and tools. This significantly reduced redundancy of onboarding and education. To further support developers, we held internal workshops in addition to creating a comprehensive wiki, enabling them to manage infrastructure and tools more effectively. Education will equip developers with the knowledge to manage infrastructure and tools. We don't rely solely on the wiki. Instead, we organize internal workshops to facilitate hands-on learning. These workshops allow developers to engage more deeply with the platform, gain practical experience, and clarify any questions they might have. The platform team plays a crucial role in this process. They act as enabler. They support and guide development teams, ensuring that they are equipped to handle the infrastructure and tools themselves. The goal is to foster a collaborative environment where learning and support are going. By the way, this is our technology stack. For the wiki, we use Atlassian's Confluence. And for the repository, we use GitHub and Azure DevOps. Additionally, you can get a sense of number of technologies and products we are dealing with through this slide. This also indicates the high cognitive load on the platform team, which I will explain later. In conclusion of these steps, the goals are a reduction redundancy of onboarding and education, and sharing knowledge. The outcomes are a decreased number of days it takes for a few new employees to do first PR, and reduction of support tickets. It means changing requests and so on, and increased tool usage. Now, let's move on to step 3, standardization and higher usability. Standardization and enhancing reusability were key to maximizing developer productivity. We utilized Terraform modules to standardize workload infrastructure and improve reusability. This allows developers to reconfigure based on their specific requirements using pre-built templates. And we have modularized each infrastructure component to make them usable, like AKS, or Azure functions, app service, a cache, or databases, and so on. It would be beneficial to achieve the following for the 6 items below. Developers don't want to think about them, and developers should ensure quality of them. As as shown on this page, governance, security, platform reliability, observability, CI/CD pipelines, scalability. They are just examples, but it applies to anything that application developers don't want to worry about and think about deeply. To summarize this step, the goal is to maximize the leverage of developer productivity. And outcomes are shortened lead time to deploy the platform and reduction of human resources spent on design and configuration. Now we will discuss step 4, self-service and IDP. As a future step, we are planning to introduce self-service and an IDP. Our goal is to improve the interface, offering options like GUI, CUI, or IAC. It depending on the developer's skills or preferences. Implementing an IDP requires specific UI/UX skills, which we are carefully considering. Here, I would like to once again quote from Wiley's article. Software developers probably already have tools and processes for managing the simplest and most commonly used paths, which aren't necessarily the same. As we move forward with this step, we must keep this in mind. It's important not to focus too much on integration. So from here, we will discuss team design. When it comes to team design, it's essential to revisit the structure based on the phase and situation of each company. As the SRE team grows, we are considering splitting responsibilities to optimize scalability. We aim to maintain a two-pizza-sized team to ensure close communication while distributing cognitive load efficiently. From here, I will explain the evolution of our team design. Let's focus to the first phase of team design. Here, we started with the smallest and simplest structure. The SRE team is responsible for platform engineering as well. In this phase, there are a few key characteristics. It's simple, allowing for close communication. With a small team, it's easier to communicate and collaborate smoothly. However, scalability becomes an issue, and cognitive load on SRE team grows. As the team expands, it becomes difficult for the SRE team to handle all tasks, leading to increased burden. Thus, while we begin with a simple approach, in the next steps, we will address these challenges as we progress. The next phase of our team design involves splitting the SRE team into a separate platform team as it grows. In this stage, the SRE team focuses on reliability of services or products, while the platform team provides variable resources such as wiki, inventory, and templates. This clear division of responsibilities allows us to operate more effectively. This table shows the differences in the responsibilities between the SRE team and the platform team. The responsibilities of the SRE team are implementing SRE practice with the developer team through embedding or enabling. And they are responsible for reliability of products or services. And this team is a customer or platform as well. On the other hand, platform teams' responsibilities are reliability of the platform, and they are focused on providing wiki, inventory, templates, and useful tools. As our next phase 3, at our current stage, we have established a cloud center of excellence to further expand platform engineering across the group. The CCOE is responsible for strategy and providing direction and best practices to the teams. This setup ensures consistency and quality across the platform throughout the group. In the future, we are considering further splitting the platform team to introduce an IDP. We aim to create specialized teams such as template team, IDP team, SRE team for platform, based on skill sets and expertise. This specialization will allow us to expand the platform's functionality and achieve greater scalability in the long term. If you like, you can further split platform team based on infrastructure layer, such as network or databases. And you can replace team design number 3 and 4, or proceed with them in parallel. It depends on situation and phase of the company and what suits for each company. So, what outcomes have we achieved through this initiative? Let's take a look. Here are the main business outcomes. Over the past 2 or 3 years, we've achieved the following results. The number of teams has increased approximately 6-fold, and the number of products has increased 5-fold. And we've reached 10 million app downloads, which is a remarkably fast pace in Japan. At the same time, the number of critical incidents has been reduced to 1/4, improving quality as well. As a result, we have improved efficiency and customer satisfaction, maximizing the value of cloud utilization and platform engineering. How do you feel that? On a different note, let's examine how we maximize our cloud maturity using HashiCorp products. By leveraging HCP Terraform and HCP Vault, we have automated infrastructure management and enhanced secret management. This has reduced our operational burden while ensuring scalability and security. Here is a technical overview of our platform. We are utilizing HCP Terraform and HCP Vault as core technologies and to manage our platform and security. As this page shows, PagerDuty or New Relic is managed on HCP Terraform. And I will explain why we chose to use the HashiCorp cloud platform. With regular Terraform, managing the state of infrastructure or running it remotely can become complex. However, HCP Terraform centralizes these tasks in the cloud. This makes it easier to maintain state consistency even when infrastructure changes are being made across distributed teams, allowing for smoother operations within larger teams. This leads to a reduction of operational burden on our team. The platform automates many manual processes, allowing us to focus on higher priority tasks. This leads to the scalability of the organization. With these capabilities, we can quickly enable dedicated Terraform usage for new teams, even as our organization continues to grow. And we are often asked why we chose Terraform over Bicep. So I will share here. The primary reason is that Terraform is the de facto standard for the infrastructure as code language. And it covers areas that a single cloud provider cannot address. Additionally, Terraform's statefile offers significant advantages for maintaining infrastructure consistency. Next, about HCP Vault. HCP Vault offers best practices for secret management, including periodic rotation, list privileges, auditing, and encryption. Its centralized management, automatic rotation, and dynamic secrets provide robust security for our platform. So we will continue to enjoy our platform engineering journey with HashiCorp products. So finally, let me share once again Aeon's philosophy. Gives a central pillar wheels. In Japanese again, 大黒柱に車をつけよ。It means adapt to changes in the environment and transform the company itself. We will continue to provide value to our customers based on this philosophy and together with HashiCorp products. So that brings us to the end of the presentation. I will be around here after the session, so please feel free to approach me if you have any questions or would like to have a discussion. Thank you very much for your attention. That's it.